Welcome everyone, and thank you for joining us today. This is Tom Christensen from Hitachi Vantara. Today I will share case studies on data-driven transformation projects that we have delivered in EMEA. And hopefully I will inspire you to embark on a similar project when you return from the event, perhaps already tomorrow. The first two use cases are from the pharmaceutical sector and one from the shipping industry. That will lead into a discussion about DataOps. And here I have a gift that I would like to give you. Afterwards, I will share insights on how you can gain control of the digital DNA, which, by the way, is the link for a CIO into a data-driven project. So without further ado, let's jump into the first slide, which is the case study about the pharmaceutical sector. This is a company located in Sweden called Vantara, a company that is helping other pharmaceutical manufacturers to put new drugs into the market. They normally analyze drug samples throughout the development process, which, by the way, can take 15 years and cost about 2 billion to create a new drug. What they do in their lab is to analyze it and come up with recommendations and give feedback to where the pharmaceutical industry is in the process and what they think they should do to have the right quality and do the documentation. They also look at blood samples to see what kind of cancer a patient might have. All of that could take up to 5 days from they got the drug sample to they have something that they can deliver back. The idea of looking at that company was to see if we could automate that process so they could stay more competitive based on insights to data. So they want to be a cognitive company, do co-creation with other companies to come up and begin to be data enabled. So let's look at the next slide. At the next slide, you can see where we started. We started with the electronic microscope, which is the device that would analyze the drug. And here we invited the company into the project. They have done more than 30 years of innovation in electronic microscope, could talk about the images, the parameters, what to look at. And then we got data engineers grabbing the data, and we got data science people understanding the parameters of what to look at, create the right algorithm to give insights to data in the organization. We engaged with the university local to that company, mainly because when we leave such a project, it's important that they still have the right people around them to continue to develop the AI and the algorithm. It's not a one-stop shop, it's a constant loop going forward. Creating that algorithm made it possible to move it from 5 days down to 1 day. Looking at the infrastructure and modernize that IT infrastructure gave us the opportunity to bring it down to about an hour. This is a really good example of how powerful it can be when you enable data, make money, save money, and stay more competitive going forward for such a company. And what I would like now is to play a video so you can hear what the customer is saying about such a project. So let's have a look at the video.
We want pharmaceuticals to be effective and we want them to be safe so that we can keep on with our lives and be happy.
There's constantly a need from the pharmaceutical companies with help of how do we characterize our products, how do we know what we have, and how do we make the right choices in our development.
We help the pharmaceutical industry to shorten time and cost to market for developing drugs. What we do is to help them use electron microscopy, everything from innovation, development, clinical trials to manufacturing. It usually costs up to $2 billion and takes up to 15 years to develop a drug today.
Our differentiator towards our competitors is that we have a full stack of business solutions for our customers, from hardware to software and then consultative services.
Vantara has a long history working in the pharmaceutical market and helping support life science companies. One thing we bring is this in-house understanding of how do you manage data, how do you validate your results, and how do you then store them in a reliable way.
This is data that is close to their research and development and possibly their revenue within the next 15 or 20 years.
That's the challenge, to be cutting edge or in the front line of the technological development. And you need to have this interaction between the latest ideas and the customer problems to have a solution.
If you're a human being, we tend to do mistakes in the long run, and just looking at the screen and counting regular structure, that is hard. It's hard to be objective and do exactly the same all the time. But luckily, computers are very good at doing that.
The more that we can automate and standardize, the more reliable both the image taking and then the image analysis is going to be in the future, and that's going to lead to more reliable and repeatable results from the technology that's really the basis of everything we do.
Then we can actually create something that has a full process that was previously quite manual.
Normally we find our clients in the cancer area or gene therapy in many different diseases. There is many different decisions and many steps to analyze. We know that that can be hard, but that is also something that we can help our clients with then, to get information for them. You can get nice images, but many don't really know what to do with them. You see your particle and then you put the images in the drawer. With the software we have, we can actually get out statistics.
With Hitachi's electron microscopy technology, we can get insight within a subvisible space.
We run through the detection and detect the particles, the objects in the images, determine the size of the particles, the shape of the particles, if they are filled or if they are empty. Do you find aggregation?
There's a lot of data coming out from electron microscopy imagery, and some of that data is very hard for a person to interpret and to really understand.
We need to obviously make sure that that data is secure and is stored in a way that we can prove to the regulatory agencies that it can't be tampered with.
That's where we utilize a lot of data power, computational power and storage power to search for structures and for interactions and other patterns. With our experience and understanding of biology, we can actually increase our knowledge on how to manufacture good pharmaceuticals for the public. And I think that's really exciting.
So what you saw in the video was about their experience as a company. And one of the statements I really like is the statement about people make mistake, machine doesn't. And that's the idea with the algorithm, and start using and automate processes, you can get speed and agility in it. Let's stop a minute and look at the shipping industry, which was another project we did. So if you go to the next slide, it's about Stena Line, which is a ferry company moving people from one harbor to another harbor in a secure way. We want to engage with that company to help them with AI and machine learning to see if we can optimize some of their manual processes. And inside a ship, you have a lot of closed loop where data are running in silos. The idea was, could we collapse that and start giving more insight? But on our first meeting with the company, and you can see that on the next slide, we basically learned that they were already in that process. They had data engineers and data science people looking at all these internal loops. But they told us one thing which was really important. They told us that the highest cost of moving people from one harbor to another harbor is based on fuel consumption. And we learned that the captain is looking at onboarding people in a secure way, make sure that he is at the harbor at the right time. But he doesn't look into fuel consumption to drive that one down. So we came back to Stena Line and we said, we think that we can look at all the external parameters around a ship. And by combining internal and external data sources, we might help them to drive down fuel consumption. So if you go to the next slide. So what we did here was we said, let's talk to the captain who's driving the ship and in control of that ship. What if we could look at the weather forecast, the size of the wave, and the way the wave is hitting the ship when it's sailing, the sea bottom, the current in the water, 20 different external parameters, and we put it into an algorithm, we would be able to calculate 3,000 routes and indicate which 4 he should select between. And if he didn't like those 4 routes, he could ask the system to come up with another 4 routes he could select between. We call this an AI captain application, which we put into the ship. It took us more than 6 months to create that algorithm, and you can see it on the next slide how it looks like. It's a neural network where we look at external parameters, we put it into an algorithm, we work with it, and we get the output. When they activated that algorithm, they could make 4 to 5% fuel reduction. By working with that algorithm over time, we could hit about 10% fuel reduction. This is a really good example of how you can enable data and help the company be more competitive going forward. Let's stop a minute and go to the next slide. So what's next? Well, the concept that we're using behind these 2 projects and other projects we do are the DataOps concept. And this is here where I would like to stop a minute and explain what DataOps is. So on the next slide, I have put together all my information around the DataOps. So if you click a little bit further, you will get more information into the slide. So DataOps is similar to what we call DevOps. DevOps is a concept where you're bringing technical teams together. So you're basically bringing development team and operational people together to make it possible to deploy application much faster. DataOps is similar in the concept, but it's basically bringing a lot of different job roles together in an organization. And these job roles are job roles that you normally have from the end user, and the end user here would be the captain or the person working in the lab we just spoke about. Those are working under a line of business person. If that line of business can see that we can achieve some benefit by automating some of the jobs they are doing, you can look at a data science person, you can look at data engineers, and you can look at all the internal and external data you got in your environment. By bringing these teams together, you can actually deliver a better solution going forward. And this is what we did with Vantara and Stena Line. I would call this being data enabled. You take a legacy company doing legacy processes and you take it step by step and you automate one process after the other one and you begin to enable a company, and eventually you will end up like a data-driven company going forward. So what do you need to think about? Well, you basically need to think about technology that makes it possible for everybody in the company to have access to data under certain rules, of course. But you also need to change the culture in such a company where you are moving the momentum out to the end user in an organization to say, hey, I got something that might be automated based on insights to data. If the business owner of that person can justify that, you can then start work on it and you can find the solution. In the middle of this slide, I'm talking a little bit about what does good look like. And this one is based on many different case studies where we have looked into many different companies, mainly in US, but also some companies in Europe. And we try to understand what process they have been through to be true data-driven. A data-driven company is a company that's living based on the data they have, and they are creating services that make them relevant in the market, or a combination of a physical product and a service that they are creating. The point here is you shouldn't start creating a data lake, pump in a lot of data, hire data science people and start innovating up data, and 2 years down the road, you haven't really created anything. The experience here is start with the problem, justify that in the organization, work your way back and find the right solution, and you can then be data enabled one step at a time. But these companies, they all went through 6 steps. First, they looked at the BI environment. They enabled that or expanded that with a data lake. Then they looked at pipelines. How do I connect and collect to all the data sources I have in my organization? Not using script, but using something more advanced to pump data in to the organization. Multi-tenancy and fair sharing. Not everybody should have access to everything. You need to figure that one out as well. Then comes the dashboard, the self-service portal, and the use of cloud. When these companies open up and move the decision to the end user, saying, hey, I want to do this today because I can see that will help me, well, you need a lot of IT to support it. That's not really possible. But if you're using cloud, you can spin it up and you can justify it. You can onboard that process into internal IT and you can run it, or you can keep it in cloud if you want that. Security and governance is important, and then the culture change. The thing for the CIO here is to have the right data at the right place when you need it. These are the link into these data-driven projects for a CIO. So let's stop a minute and look at how do I get more value out of my data. So if you go to the next slide. We often, when we engage with customers in these projects, we often get the questions, how do I get more value out of the data I have? I want to make money, save money, stay more competitive by insights to data. But the reality is different. The reality is that most companies, they're swimming in data, but they're struggling for information and insights. And what happens here is that what is the value of data if you can't find it? Perhaps nothing, or perhaps a big risk if you're a compliance officer. If you have big data black holes in your organization, you don't see all the transactions that you should see. You need access to data in order to be on top of what is going on inside the bank. Why did we end up like this in almost all organizations? When we organize a company, we divide it in multiple departments working in silos. This is no different from the data landscape. It's created by application that is tight connected to the data, delivering a service for that department. And suddenly, you're ending up with thousands of applications scattered all over the organization, running in a decentralized environment, not being in control of all the data. You can't deliver the data at the right time, at the right place when you need it, if you are in such a situation. How are we doing today? Let's have a look at the next slide and see what we are actually doing. So this slide here is based on input from Harvard Business Review in 2017. And they're basically telling us that on a worldwide level, it's less than 50% of all the structured data that are used for decision making. 50% of all the structured data are not used. Structured data are not that difficult to work with. You can always ask a question and you will get the query back and you will get the information you're looking at. But still, it's only 50% of the data we're using. A big risk for a compliance officer. If we then turn around and we look at the right side of the slide, we can see unstructured data, which by the way is 80% of all the data we have in the data landscape. 80%, and we're only using 1% for decision making. You really need here to get structured around unstructured data before you can start using it and give value back to the organization. So let me give you an example of how you can get structured around unstructured data. The video we're doing today will end up on a file share somewhere, like a file with some attributes. When was it created? When was it last accessed? And who have modified that file. It doesn't really describe what we're talking about. This is similar to the voice recording you're doing when you talk to the bank, the insurance company, the healthcare organization, private public companies that are recording conversations. These end up like files and you don't know what is going on these files. So if you take out the communication in clear text and you put it into metadata and put it around the file, you suddenly can search and you can index these files and you can get value out of it again. metadata becomes really important in getting control of all the data you have in your organization. And you need to think about a unified way of implementing the metadata. Metadata will be more important than the file itself going forward. So, how do you set yourself up for success here? Well, you need to connect and collect to all data sources, structured, unstructured, semi-structured data in your organization. You need to think about index and search capabilities across the organization in a decentralized environment. You need to think about using AI for scale, otherwise it becomes really difficult. The companies that we engage with, they can get the process of connect and collect, index and search up, but it's very difficult for companies to use AI for scale in such a solution going forward. And this is what you need. So if we look at the next slide, and this slide is an example that we have used for global banks when we deliver solutions to those global banks. If they want to have a single source of truth where they can find information for compliance officers, internal investigation, or maybe people who are responsible for service or marketing in the bank, a CIO needs to spend 80% of his work on how to get the most fundamentals right about the data, connect, collect, index, search to all the different applications and data he has in his environment. He needs to figure out where to place it. Data lake has been known for many years, but data lakes could actually be a bottleneck. If you just dump a lot of data in it, it could end up like a data swamp. Maybe you should think about something more clever where you can save your data. 20% of the solution will be used by end users searching and finding information in such a solution. So if we go to the next slide, I think you need to go to the next slide again. This one here is a slide that is showing you the data platform, which is a concept that you can use and be inspired by. It's a platform that we're using in our projects. And let me walk you through this one and explain why this could be more interesting than a data lake. It's a non-proprietary concept that can apply to the toolkit you already have in your environment. It's basically based on the left side, internal and external data. You need to ingest that by pipeline or script. Once it comes into that platform, you need AI to look at data. Why is that? Well, the unstructured data needs to be fixed here. So if I'm a bank customer and I got a bank account, my name, first name, last name, zip code, and amount of money and transaction I'm doing in that application will be known by that application. If I'm also using a different service, which is the pension service, well, my first name, last name, zip code, and all the shares I'm investing in will be in that application. There might be another application I'm using and another one. If you dump in all that data, it comes in different formats. It makes it very difficult to work with. But by having a unique format with metadata, you can streamline it and you can actually compress data in that transform process. You don't need a catalog where you can open up and give access to data. Security is important. Could be Collibra, it could be other kind of security tools you're already using. Some customers would like to use ServiceNow as the interface where they open up for the marketplace, where people get access to data. Product service owners, marketing people, compliance officers, internal investigation, and so on can go in with the right and search for data in such a solution. In overall, that concept is about taking raw data, curate it, and publish that internal in the organization. And it has proven to be a success when you start using this one here. So if you go to the next slide, this is just a little bit about the compliance solution. If you're using data, predictive analytic, and automation, which is, by the way, the essence of a modern compliance solution of today, regulators, they don't want verbal assurance of a process that you might have in the bank to document you can find things. They want real proof nowadays. They're tired of what happened in 2008 with the financial crisis. People were not in control of data. We need to get to the point where we're in control of data, where we don't have data black holes and things we're not aware of. You need to figure that one out so you can document that you got a single source of truth where you can search and you can find information. But you also need to consider, how do I break down silos in this landscape you have? Breaking down silos doesn't mean that you have to delete it. Keep it where it is. It's decentralized, but connect and collect, put the right thing around it so you have data with the right metadata so you can search and you can find it. That will eventually drive down cost for such a solution going forward. So if we go to the next slide, I'm beginning to come to the end of my presentation. I hope I gave you something and inspired you about what is important to think about. And I think here at the end that if you want to get in control of the digital DNA, you basically need to make sure that the CIO can deliver access to data, so you have the right data at the right place when you need it in these data-driven projects going forward. And with that, I hope I have inspired you about some of the experience that we have. If you want to reach out to me or some of my colleagues, please ask for a one-to-one meeting during this event, and we can sit down and have a discussion about what you're doing and what the next step could be. With that, thank you for listening to us.